In this lecture, we are going to discuss about electric field intensity on equatorial line due to an electric dipole. What is the heading? Electric field intensity on equatorial line due to an electric dipole. Due to an electric dipole. Most important derivation. Most important. Okay. Electric field intensity on equatorial line due to an electric dipole. So first we will consider the diagram. According to diagram, we will find the derivation. Okay, it means final formula. Okay, let us see. We have an electric dipole. You know very well what is the electric dipole. Electric dipole is a pair of two equal and opposite point charges at certain distance, either short distance. Okay, so if suppose that you are taking here, this is a one negative q charge, this is a one positive q charge, and you can place the name this point charge A, and you can place the name this point charge B, and you are going to take one centered point like this. So centered point you can just consider like this. So centered point you can place the name O, and you can take the distance between these 2 point charges. You know very well what distance you can consider here, 2a. Is it okay or not? Okay. Now, so what we are going to do, we are going to find electric field here, and you can just like this. If suppose that you are going to, you know very well, electric field always, if suppose that we are going to get the direction of the electric field, so it will be away from the positive charge and towards the negative charge. You know very well, yes or no? It means if suppose that you are going to take electric field at point P, you can write the point here P. We need to find electric field here at P. So electric field at P, it will be away from the positive charge. So away from the positive charge means you are going to take this side. It means you are going to take this one E1. Is it okay or not? And now according to this, according to this charge, you are going to find electric field at P. So it will be towards the negative charge. Is it okay or not? So now it will be like this. This is a E2. Any doubt? If suppose that you are considering here angle theta, okay, so now you can rough this one like this. Any doubt or not? But we need to find resultant electric field. So resultant electric field, you are going to find resultant electric field. So better explanation, for better explanation you can see here. See, this is a vertical component, and you are going to get, this is a horizontal component, yes or no? This is a vertical component, this is a horizontal component. So vertical component you can write here E1 sin theta, and here you can write E2 sin theta. Both are equal and opposite, will cancel, finish, yes or no? After this one we have only that horizontal component. So horizontal component, see, one you are taking like this one E1 you are considering, and here you are going to consider E2, yes or no? E1 E2, understood according to this diagram. So now you are going to get that resultant. So resultant means you are going to get that resultant, so it will be here. So it will be E is equal to E1 cos theta plus E2 cos theta. Is it okay or not? So it means both E1 and E2 will be same. How we can say it will be same or not? So for that one, what you can consider, this distance you can consider R. Here O2 P, you can consider R. So this total is a 2A. So here to here will be A. Yes or no? And similarly here to here will be also A. Yes or no? So this is a base, this is a height, either perpendicular. So you can find this distance. So it will be R square plus A square. Yes or no? Similarly here also it will be R square plus A square. This distance here to here and here to here. Is it okay or not? Now you need to find resultant electric field. So it will be like this. So this is a resultant electric field. So according to this one, distance are same, charges in magnitude both are same. So resultant will be, you can write here, E1 E2 will be equal. So E1 and E2 will be equal. So you can write here like this. So you can write here E1 cos theta plus E2 cos theta. Yes or no? In calculation we will get, no problems. Here I am not writing, either you can write here, no problem, but in calculation we will complete it. Yes or no? So now what we can do here, electric field at P due to this positive Q charge. So now electric field at P due to positive Q charge. Yes or no? So you can write here E1 is equal to 1 upon 4 pi epsilon naught into Q. So Q upon R square, it means distance is square. So what is the distance? Here to here root. So root R square plus A square whole square. This one equation first. What is the direction? Away from positive charge. So you can write here away from positive Q. Is it okay or not? Similarly electric field at P due to negative Q charge, so it means you are going to write here E2 is equal to 1 upon 4 pi epsilon naught into Q upon, here you will take only magnitude form. It means negative Q charge magnitude will be positive. Do remember this thing. So now, so what you can write here, R square plus A square whole square equation 2. Here you can write towards the negative charge, negative Q. Direction is this side. Is it okay or not? So now you can see both are same. Here is also Q upon root R square plus A square whole square. Here is also same, Q upon root R square plus A square whole square, root R square plus A square whole square. Both are same. Is it okay or not? After this, resultant electric field at P. So now resultant electric field at P. So resultant electric field at P are going to find. So now it will be according to diagram E1 cos theta plus E2 cos theta. Is it okay or not? Till here any doubt? No doubt. So now we know very well, because E1 is equal to E2, both are same. Yes or no? So now you can just write here E is equal to 2 E1 cos theta. So now you can place the value. So E is equal to 2 E1 1 upon 4 pi epsilon naught Q upon, if suppose that you are going to square this root, you are going to do square of this root. So root will cancel with this square. So you can write here only R square plus A square. Here you can write cos theta. Is it okay or not? So now you can write E is equal to 1 upon 4 pi epsilon naught into 2q upon r square plus a square into cos theta. This is not a final equation. You got this equation in the form of cos theta. So from where you will get the cos theta value? So cos theta you can apply here in this triangle BOP. You can apply here. So cos theta you know very well according to diagram. According to diagram cos theta is equal to theta is there na, base upon hypotenuse. So base upon hypotenuse means you can write base OB hypotenuse PO या BP. Base upon hypotenuse. Base upon hypotenuse. Base upon cos theta is equal to cos theta base upon hypotenuse. So base you can write OB, hypotenuse you can write BP. So base means A, you can see here, A upon hypotenuse root over r square plus a square. Now you can place this value here. So you can write, what you can write? You can write here E is equal to 1 upon 4 pi epsilon naught into 2q upon r square plus a square into cos theta, A upon root r square plus a square. You know very well, we can write E is equal to 1 upon 4 pi epsilon naught 2qa divided by c root r square plus a square. It means we can write like this also, r square plus a square, we can write here r square plus a square power 1 by 2. Yes or no? Upside we know very well electric dipole moment, because we know electric dipole moment P is equal to Q into 2A. Here we can place. So we can write here E is equal to, we can write 1 upon 4 pi epsilon naught into, what we can write here, Q into 2 into A, 2A divided by r square plus a square power 3 by 2. 1 upon 2 power 1, 1 plus 1 by 2, 3 by 2. Here also see, this is a, this is a r. As compared to this r, this a is a very small. So what we can consider here, what we can write here, okay. So here we can write E is equal to 1 upon 4 pi epsilon naught into, here we can write P is equal to Q into 2A. It means P upon, here we can write r square power 3 by 2, because r is much greater than A. This r is much greater than A. So we can neglect this one, A we can neglect. So this 2 will cancel. So finally we can write E is equal to 1 upon 4 pi epsilon naught into P upon R cube. P upon R cube. So this is the final answer, Newton per Coulomb. Do remember one thing, if you want to write in a vector form, what you are going to write in vector form? Here I am writing, okay, in vector form, in vector notation. In vector notation, if you will write, so you can write E is equal to negative of 1 upon 4 pi epsilon naught, vector E is equal to negative of 1 upon 4 pi epsilon naught P upon R cube, Newton per Coulomb. Only negative sign will come. Why? Because of direction of the electric field. Is it okay or not? Till here any doubt? No doubt. If you have any query, any problem, any doubt, so you please give the comment also, and you can just join the WhatsApp group. And I have a humble request, you can subscribe this channel for upcoming lecture. Thank you so much. We will see you in the next lecture.